Swayam Prabha. Digital India. Educated India.
Hello everyone, today we will continue with the lecture on Euler angles, Euler space and ODFs, that is orientation distribution function. So, we are continuing with the module 4, that is texture representation for the course texture in materials, right. So, in this lecture we will cover the concepts regarding understanding texture representation in Euler space and orientation distribution function, relationship between crystal orientation, that is the orientation of the crystal with respect to important sample reference planes and direction HKL UVW, right, the rolling plane and the rolling direction in case of the rolled specimen, in terms of the Euler angle phi 1 phi phi 2, which is basically used to observe the Euler space. So, let us start with demonstrating the cube texture component, that is the 100,001 components using the Euler angles, that is in the Euler space. We have already observed the cube texture component as an example for the formation of a component in cubic crystals. So, these demonstrations that I will be doing here is basically related to the cubic crystal. So, let us say that there is a sample which has been rolled, and so the important sample reference directions are RD, ND and TD, right, and the crystals which are oriented in this sample are mostly oriented same like this. So, x is basically 100, y is basically 010 and z is 001. So, the cube component, as we have discussed earlier, can be observed in this corner, in this corner, in this corner and in all the 8 corners of the Euler space, that which are related to 0 0 0 degree of phi 1 phi phi 2, 0 90 0, 0 0 90, 90 0 0, 0 90 90, 90 90 90 and all the combinations of 0 and 90s in the phi 1 phi phi 2s, right. Now, let us demonstrate it how we can obtain it from this sample crystal relationship. So, let us say that we draw a RD, TD, ND axis of the sample like this, and similarly we can observe from this figure here that x is 100, that is the crystal coordinate system, 010 that is the another crystal coordinate system, and 001, right. So, you see that RD is parallel to 100, TD is kept parallel to 010 and ND is kept parallel to 001. So, if we want to find the Euler angles phi 1 phi phi 2, then the first condition is that we have to make ND parallel to some 100 and RD parallel to another 100, making it a cube texture component, right. So, if initially I give a rotation of 0 degree along phi 1, that is a rotation of 0 degree along ND of the specimen axis, and then we give, then the RD remains at 100, the TD remains at 010 and ND will be 001 because we are rotating about ND. So, ND is not moving, and then if we rotate again phi by 0 degree, the ND and TD remains the same along with RD, and then again if we rotate by 0 degree along phi 2. So, the specimen axis is not rotated at all with respect to this crystallographic axis, right. So, what we are doing is we are obtaining the first Euler angles for the cubic HKL UVW orientation of ND, which is basically 0 0 1, right. ND is parallel to 0 0 1 and RD is parallel to 1 0 0, right. Now, therefore, if we are drawing, say for example, we draw this Euler space again, right, the same Euler space that has been drawn in this side, I am trying to draw it again, then what will happen? Then this is the Euler space, right. So, this is 0 degree, this is 90 degree, this is again 90 degree, and considering the crystal symmetry for the the cubic crystal, you can observe that there is fourfold symmetry along 1 0 0 axis, which makes the Euler angle fixed at 0 to 90 degrees for phi 1, phi and phi 2, and we will discuss this also later in detail. So, say this is phi 1, say this is phi, and say this is phi 2, right, and these are going like this, right. Now, we see that the first position 0 0 0 degree is basically this position, right. Now, therefore, if we take this component and we can say that this component is basically related to 1 0 0, sorry, it's a small mistake. Zero 0 1 and 1 0 0, right. Now, let us take another component and let us say that I am rotating this phi 1 phi 2 by say 90 degrees, 0 degrees and 0 degrees. And so, we have to rotate phi 1 by 90 degrees, that means that we have to rotate ND, that is this one, by 90 degrees using the right hand thumb rule, right. So, I have to rotate something like this. Let us use another pen and let me show you how the rotation is done. So, I am rotating it by the right hand thumb rule like this, right. So, initially this was the case 1 and now the case 2 that I would like to show is rotating the ND by 90 degrees. What we can obtain is the RD is rotated and it goes towards TD, and the TD is rotated by 90 and goes towards parallel to RD. So, now the second case becomes ND is on the top, RD is now parallel to the initial TD and the TD is here, right. So, this is the second case, and in this case what happens that ND remains parallel to 0 0 1 and RD becomes parallel to 0 1 0, right. So, the position 90 0 0 can be shown here in the Euler space at phi 1 equal to 90, phi equal to 0 and phi 2 equal to 0, and that becomes equal to this position, and that becomes equal to 0 0 1 0 1 0, right. And you see, and if we continue doing this for the third example, what we can see 0 degree, 90 degree, 90 degree can be done, and thus if we do that, what happens that if we take the third condition, that is this third condition, we have to rotate by phi equal to 90 degrees. That means the rotation has to be done along RD, right. The rotation has to be done along RD using the right hand thumb rule, and which is like this, right. Let me take another color and let me show you that this has to be something like that, right. Now, if such a situation exists, then the phi 1, phi 2, 0, 90, 0 degree, okay. Let me take this, and 0 degree can be shown by rotating RD by 90 degrees, so that the TD comes vertical like this and the ND comes out like this, right. So, ND just comes out opposite of TD. Now, if ND is like this, then the ND is basically 0 1 bar 0, right, and the TD the RD is basically 1 0 0. So, the position of the another pole of the cube component is basically at 0, 90, 0. So, phi 1 is 0, phi equal to 90 and phi 2 is 0. So, this is the position, right. Another position we can find out like this. Similar way, if we go ahead and this situation where phi 2 equal to 90 is given, following phi 1 equal to 0 and phi equal to 0 is similar to that of the second situation, which where phi 1 is given 90 degree rotation. So, you see that this is a situation where we are giving a rotation like this similar. Let me show you that 4 is basically similar to this one, where we have rotated using the right hand thumb rule ND by 90 degree. So, RD is here and TD is here. So, you see that this is 0, 0, 90. So, this is a position where this will form. Let me show. So, this is the position of another cube component, which is basically having a texture of, in terms of Miller indices, if you say 0, 0, 1, 0, 1, 0, right. And like that, if we look into, you see fifth one, where we are rotating by, you see 90 degree, and then we are rotating again by 90 degree along phi and then by 0 degree. That means, we are taking the 2 and we are rotating by phi equal to 90 degrees, right, which is given along RD. So, if we are taking this section, TD and you see ND, and then we are taking RD, and then if we are rotating along RD, right, using the right hand thumb rule again, right, like this, then what happens is that ND rotates and it forms here, whereas TD, which is here, now forms here, right, whereas ND the RD remains at the same position. So, the fifth position is basically ND is parallel to 1 0 0, whereas RD is parallel to 0 1 0, right. So, we can write 90 90 0, that is basically phi 1 90, phi 90 and phi 2 equal to 0 can be kept here, and this is another component 1 0 0 0 1 0, right. Now, if we go ahead and do this for, you see, the sixth section, that is, you see 0 degree, 90 degree and 90 degree, and if we do this, what will happen? We have to take the phi equal to 90 degree, that is the third one, this one, and then we have to rotate by phi 2 equal to 90 degrees, right. And now, how this will happen? Let us take this one, which is given here, right. Now, we take this TD, this ND and this RD, right, and we give a rotation by using the right hand thumb rule, right, the right hand thumb rule like this. Let me use another color, so as to you for understand, and then what will happen, that the RD will go at the top and the TD will go here and ND will remain at the same position. So, ND basically becomes 0 1 bar 0 and RD becomes 0 0 1, right, and this is a position 0 90 0. So, 0 90 and then 0. So, this is a position which is shown by this. Like that, if we go ahead and do the seventh one, that is 90 degree at phi 1, 0 degree at phi and then again 90 degree at phi 2, then what will happen, that we have to take the 2 and then rotate by phi 2 at 90 degrees. So, if we take the 2 1, then this is like this, and then you see this is the second one. So, this is N d, this is R d, and this is T d for the second one 90 0 0, and then we are rotating again by 90 degrees along N d, right, because it is a phi 2 equal to 90 degree rotation, and thus what will happen, that the R d will come here, right, and the T d will come here, and the N d will come here, right. So, you see that in this way we have traced almost all the phi 1 phi 2's respect to the cube components in the Euler space, and you see this was 90 0 90. So, it is 90 and then it is 0 along phi and then again 90. So, this position is here, and like that you see that we can devise the 8th one, which is 90 degree, 90 degree and 90 degree. So, in order to do so, we can take the 5th solved axis, which is basically N d, R d and T d, and then rotate the 5th one by phi 2 equal to 90 degrees. So, what we are doing, basically we are taking the N d here and rotating it like this using the right hand thumb rule, so that the N d remains the same, right. The R d, because we are rotating like that, so R d comes up. So, this is R d and the T d comes here. So, thereby we also obtain the position of the cube component at this. So, you see there are cube components present in all the 8 corners. However, there are more cube components present, and these cube components which are present in this Euler space are also shown in terms of the the fiber which is shown here, right, this fiber. Now, how it can be shown? Now, you see that if we take the the 9th, sorry, I will change the color, the 9th situation, where if we rotate by phi 1 phi 2 by 10 degree 0 degree, and then I have to rotate phi 2 by 80 degrees. So, that phi 1 plus phi 2 becomes 90, and it is basically a rotation along N d by 90 degrees divided among phi 1 and phi 2, right. So, and then we can do this for 20 degrees at 70 degree, 20 degree phi 1 and phi 2 at 70 degree, then the 11th case 30 degree and 60 degrees, right, and the other cases, right, 12th case like 40 degrees and 50 degrees, right, and like that you see 50 degrees and 40 and 60 0 30 and 70 0 20 80 0 10, right. So, you see that let us take phi 1 equal to 80, phi equal to 0 and phi 2 equal to 10 degrees, right, in this Euler space, and we can observe that if we look phi 1 equal to 80, it will be somewhere here, right, and then if we take phi equal to 10, it will be sorry phi 2 equal to 10, it will be somewhere here. So, let us use some other color, right. So, some one here, and then if we trace this point, and then we see that this is related to this component, right. Similarly, we can trace 70 20 somewhere here, 60 30 somewhere here, and then we can relate everything, and then you see that basically it is forming a fiber here. So, like that you see the cube component in an Euler space not only form components at the corner, but also forms a fiber in the phi 1 phi 2 plane, where phi is equal to 0. Now, this cube component that we have devised using the Euler space can be shown using the pole figures, and here you can see that this is the 1 0 0 pole figure, which shows the positions of the cube components in terms of 1 0 0 poles. Here is the 1 1 1 pole figure, and all this we have described in previous lectures. These are the 1 1 0 poles, which shows the same texture, and this is the 1 1 1 pole figure, which shows the positions of this cube component here in terms of 1 1 1 pole. And similarly, you see inverse pole figures can also be used to show these texture components. Right. Now, you see that in the inverse pole figure one can easily find out that the position of 1 0 0 should be for the RD. Right. Similarly, for the ND the position is again 1 0 0, and thereby as 1 0 0, 0 0 1 and 0 1 0 are perpendicular to each other. Therefore, you see the TD also comes along 1 0 0. So, this is the way we can demonstrate the the texture in terms of pole Euler space, in terms of pole figure, in terms of inverse pole figure. Now, you see it is difficult to observe this situation in the Euler space, and therefore, what we do basically is, instead of showing the Euler space which shows this positions of the cube orientations, and I am drawing it once again for your convenience, 0 degree, 90 degree, 90 degrees and 90 degrees here, and this is phi section, this is phi 1 section, this is phi 2 section, and you can see that the positions of the cube components are this, 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 this and this. And if we look, we can see that here we also have fiber which actually shows the cube component, right. However, instead of showing it in terms of Euler space like this, what we basically do, we show them in terms of ODFs, which basically we show in terms of phi 2 sections most of the time, but that does not mean that we cannot show the ODFs in phi sections or phi 1 sections. It depends that when and what is required is shown for clarification and for easy analysis. So, you see that if we divide this Euler space into phi 2 sections, say let us say that we take this particular plane and we draw it here, and we show that okay, this is phi 2 equal to 0, right, and then you see this is phi 1 and this is phi, and so this is 0 for phi 1 and 90 degree, and this is 0 for phi and 90 degree here, and like that we can slice this Euler space at 5 degrees or 10 degree graduation, right, like this many, and like that if we show the phi 2 equal to 10 degree section and phi 2 equal to 20 degree section, and like that, you see I am drawing it a little faster, so it may not be so beautiful, but I am trying to show you something that will help you in understanding the representation of the texture, where phi 2 equal to 0, 10, 20, 30, 40, 50, 60, 70, 80 and 90 degrees. Then the position of the cube components at phi 2 equal to 0 degrees are the corner positions, right. So, it will be shown somewhere here, somewhere here and somewhere here, and similarly when at phi 2 equal to 90 degree section, it is shown again in the corner. So, it will be shown here and here, right. Now, if we look into phi 2 equal to 10 degree section, the position will be somewhere, you see, at phi 1 equal to 80 degrees, right, as we have said. So, we will find the position here at phi 2 equal to 20 degree, the phi 1 position will be at 70 degrees, and then at 30 degrees it will be at 60 degrees, and at 40 degree it will be at 50 degrees, at 50 degrees it will be at 40 degrees, and at 60 degrees it will be at 30 degrees, and then 20 degrees and 10 degrees, and at 0 degrees. So, this is how the cube components basically look when we observe them in the orientation distribution function. So, that is all for the cube component. So, in this way we can observe that how cube texture can be represented using the Euler space and the orientation distribution functions in phi 2 equal to 0 to 90 degree sections, which can be graduated at 5 degrees or 10 degrees as suitable. Thank you very much.